This is part 6 of the Module 3 lecture. This is on box and whisker plots. This corresponds to the section 3.6 in the text. All right, the box plot is a graphical display based on the 5-number summary statistics. And in the previous section, we learned how to produce these 5-number summary statistics. And the box in the box and whisker plot displays the first quartile, the second, and the third quartile, as you can see in this diagram. So the bottom of the box is located at where the first quartile value is, and the upper part is at where the third quartile is. And the line in the middle, or somewhere in the box, designates or marks the location of the median. Now the whiskers, the lower and upper whiskers, they extend either to the minimum value in the data set for the lower whiskers, or something that we call the lower inner fence value. And the upper whisker extends to the smallest of the maximum value in the data set, or the upper inner fence value. All right, let's talk about these inner fence values. The lower inner fence value and the upper inner fence value are given by these equations. So the LIF, or the lower inner fence, is just the first quartile minus 1.5 times the interquartile range. Whereas the upper inner fence, or the UIF, is just the third quartile plus 1.5 times the interquartile range. So the lower whisker will extend from Q1 to the largest of either the lower inner fence value or the minimum value. Whereas the upper whisker will extend from the third quartile to the smallest of either the upper inner fence value or the maximum value. Now, if there are observations in the data set that fall outside of the upper or lower whiskers, we will consider those outlier values. And they will be displayed with either an asterisk or a dot. And this choice of asterisk or a dot will depend on the software package that you decide to use. Also, I wanted to mention that here at the top, I'm calling these box plots. I know the original name were box and whiskers, but now if you look at software packages, most people call them just box plots, and most people just refer to them as box plots. All right, let's look at an example. This is the same example that we completed in the previous section, where we have the 11 values of sales given in US dollars. And we already calculated the 5 statistic summary, and here it is. So we have the minimum, the first quartile, the median, the third quartile, the maximum, and the interquartile range. All right, so the first step is we just draw a line and mark the scale for the sales in US dollars. Once we have that, then we look at where 5.9 is. That's the first quartile, and it's right here on our scale, so we draw a line right there. Then we look for where the third quartile is. So this is 11.3, and 11.3 is located here. And then we close the box. So closing the box, then it just shows a distance from the first quartile to the third quartile. The height of the box is meaningless in this case. It's just the way this graph was designed. Then we find the median, and median is 9.8, which is right here, and we draw a vertical line here. So that's the box itself, and it displays the 3 quartiles: first quartile, the second quartile, and the third quartile. All right, so now next let's figure out how long the whiskers are in this plot. All right, so let's calculate the inner fences. So the lower inner fence is the first quartile, 5.9, minus 1.5 times the interquartile range, right here, 5.4. If you carry out that calculation, you obtain minus 2.2. The upper inner fence is just the third quartile, 11.3, plus 1.5 times the interquartile range, 5.4. Again, if you do that calculation, you obtain 19.4. So now we determine the length of the whiskers, now that we know these inner fence values. So the largest of the lower inner fence value and the maximum value is, of course, the minimum value. So the largest between minus 2.2 and 3.9, of course, is 3.9. So the lower whisker will extend from Q1 to the minimum value. So the smallest of the upper inner fence and the maximum value, so right here, 19.4, the minimum of between this number and that number is 15.5. So the upper whisker will extend from the third quartile to the maximum value. And if you think about this, this makes a lot of sense, because if you happen to use these two numbers, it will give the impression that you have data values between minus 2.2 and 19.4, and this is false, because we only have values between 3.9 and 15.5. So remember, the box plot has to represent the actual data that was observed. So we cannot invent a graph based on new values. That will be a misleading graph. All right, with that knowledge, we will complete the graph. So here's the box plot that we drew a minute ago. And now we can draw the whiskers. We know that the lower whisker goes from the first quartile to the minimum, and the upper whisker from the from the third quartile to the maximum value. So there is the box plot. That's it. And now, what is the box plot telling us? Well, the line in here in the middle, or between the third quartile, the first quartile and the third quartile, is the median. That tells us that 50% of the data is below the median, 11.3, and 50% of the data is above 11.3. The size of the box tells us the interquartile range. In other words, this is a measure of variability. The size of the box tells us how variable the data is. And also, you know from the previous section that the size of the box represents the middle 50% of the data. And the whiskers give you an idea of the range of the data. All right, so how do we use these box plots? By itself, perhaps it's not very meaningful. And the box plots not only show you the median and the variability, or the measure of location and the measure of dispersion, they also give you an idea of the shape of the frequency distribution. Let's look at that before we talk about interpreting the box plots. All right, so if you have a symmetric distribution, then you will see that the median is very much in the middle between the first quartile and the third quartile. Also, the whiskers are about the same length. And if you have any outliers, you may see outliers on the left and on the right. The fact that you have the median in the middle of the box and the whiskers are about the same size, that's telling you that you have a frequency distribution that is approximately symmetric. Now, if you have a right or positive skewed distribution, then you see the bulk of the data is on the left side. And that's why the median appears closer to the first quartile. And only that, the lower whisker is shorter than the upper whisker, and often you will see outliers on the right-hand side. So this shape is telling you that the frequency distribution is right skewed or positive skewed. Now, if you have a left or negative skewed distribution, now the bulk of the data is on the upper part of the scale. And then therefore, the median now is going to be closer to the third quartile. And only that, the upper whisker will be shorter than the lower whisker, and the outliers will appear on the left side. So all of this together is telling you that you have a left or negative skewed distribution. All right, so again, look at these three figures and make sure that you keep in mind the tell signs of the shape of the distribution. All right, let's look at some two examples. Here's the first example. In this case, we're comparing the weight of male and female athletes, and their weight is measured in kilograms. So the left graph corresponds to the females, and you can see that it's showing you the median weight. And on the right-hand side, we have the box for males. And you can tell right away that the median weight of the male athletes is much higher than the median weight of the female athletes. Now look at the size of the box. The box of weights for the females is much smaller than that for males. So this is telling you that the weight of the male athletes is more variable than the female athletes is. Now, if you look at the female athletes' box plot for their weights, then you see that the medium is closer to the first quartile. The lower whisker is shorter than the upper whisker, and there is an asterisk on the upper side. These are the tell signs of a positively skewed distribution. So the weight of the females are positively skewed towards the high weights. And in fact, there is one athlete that is pretty heavy compared to the rest, and this lady weighs about 70 kilograms. On the male side, I think you will see that this is more of a symmetric distribution, even though the medium is a little closer to the third quartile, but the whiskers are about the same size. So I will argue that this is a little more symmetric, the weights of the male athletes. But you can see everything that we can say about comparing these two groups. And I summarize that comparison here on the right-hand side. Here's another example. Now, in this case, these two box plots compare the reaction time in seconds of individuals that did not drink alcohol and individuals that drank alcohol. And let's follow the procedure. So let's compare the mediums first. Well, then you can see that the medium reaction weight of those that consume alcohol is, the reaction time is longer than those that did not consume alcohol. So these people that didn't consume alcohol, the reaction time is about a second shorter than those that consume alcohol. Now, if we look at the size of the boxes, the group that consume alcohol, the reaction times are more variable than those that did not consume alcohol. Now, if you look at the distribution, frequency distribution of those that consume alcohol, then you see that the medium is closer to the first quartile, the lower tail is shorter than the upper tail, and there is an asterisk up here. So that the distribution of reaction times is skewed towards the longer times. So that means consuming alcohol will tend to slow down most people. And if we look at the reaction time for those that didn't consume alcohol, well, again, the medium appears in the middle of the box, but the lower tail is shorter than the upper tail. So there may be an indication that this distribution is also skewed towards the positive numbers. But again, we can conclude in general that consuming alcohol decreases the medium reaction time, and there is more variability in those reaction times. All right, so I hope these two examples help you to see how we interpret box plots. And this is what I'm going to focus the most whenever we talk about box plots. So in the exam, rather than having you build a box plot, or rather have you figure out the quartiles and all of that, I'm going to rather present you with graphs and ask you to explain the graphs. And I'm doing that because just about every software package is able to build box plots. Even Excel produces box plots. So it's rare that you will have to do this by hand. So the focus will be on the interpretation of these graphs, because that's what you're going to find in your professional life in the future. All right. So this is the end of module 3. I don't know why I have module 2. I will change that. But this is module 3. And there's an assignment for each section. And the topics that I did not cover, like 3.14, you will not see any assignment or any questions, any assignments on that, or any questions on the quiz or exams on that. I will only focus on what I cover on the slides. Check the due date for these assignments, or you can see the calendar on Wiley+. All right, at this point, you should be able to distinguish between a parameter and a statistic, list the measures of centrality and their advantages and disadvantages, list the measure of dispersions as well as their advantages and disadvantages, determine the proportion of observations within an interval about the mean, list the measures of position and be able to explain their meaning, explain the construction of a box plot and be able to explain what it represents, and explain a graph that compares two groups using box plots. So you should be able to do all of this by the end of this module. Thank you.